In this video, we are going to be talking about orientation vectors for MSC Nastran beam elements. Now, this is going to be helpful if you're using other types of Nastran because they tend to use the same format. Here in this example are some beam elements, and the purple lines are the orientation vectors. Now, ideally, you would want some consistency when it comes to the beam orientation vectors like you see here on the screen, but the problem we're having at the beginning of this video, the orientation vectors that we define are not correct. If we look at the orientation of these beams, you can see that the beam orientations vary as you go along the circumference of the cylinder. Some of the beam cross sections are actually interfering with the wall of the cylinder. So we want to fix this, and that's the focus of this video. How do we take bad orientation vectors like these vectors? How do we fix them so we get something more consistent like you see here on these other set of beams? Now, the tool we are going to be using today is called the Pre-Post Web App. This is part of the Soul 200 Web App. Now, if you want to follow along with this tutorial, you can visit theengineeringlab.com. At the top right hand corner, there's a blue button, Free Trial Pre-Post Web App. Click that link, fill out the form, and we'll go ahead and grant you access to the tool we are going to be using today. Now, the story today starts in Patran. Now, depending on the skill, the years of experience, depending on the program. Now, this is not only true for Patran. You might have some success with the beam orientation vectors. You may not have some success with the orientation vectors. So here, well, we've tried and it really didn't work out. We tried modifying the beam orientation vector here in Patran, but it didn't work for us today. So this is what we're going to do. We are going to export this model. Let's go ahead and do that right now. And so this model is going to contain our Nastran model of those beams and the elements here. You can see all the C-bar elements are here. It's the orientation vector for these beam elements that's not correct. So now that we have that on our desktop, let's go ahead and copy it over to this other directory. Now, what I can do, or at least what you can do once you get access to this tool, you can open up the viewer. And let's go ahead and import that cylinder model. And let's go ahead and display the beam shapes, if you will. And if we look at the beam shapes, you can see that there's no consistency. So as we go around the circumference, some of the beam shapes are interfering with the wall. If we rotate the cylinder, if you will, you can see the orientations are completely off. Now, if you want to look at what the orientations look like, you could go to the FEM label tool. Here you can click on display orientation vectors. And this will go ahead and display some orientation vectors for you. So that would be these purple lines. And here this demonstrates that the orientation vectors are not consistent here. We have to fix this. Now, let's go ahead and hide the cylinder for now. And let's go ahead and talk more about the vectors. Now, whenever you define a vector, I think it might help if I hide some of this. Whenever you talk about a vector, you have to ask in what reference frame, in what coordinate system are those vectors being defined. So how do you find that out here in the tool? If you go to the FEM label tool, you can click on this button called Display Displacement CS or Coordinate System. And then this is going to display small coordinate systems. These are going to be the degrees of freedom for each node. So here are just some examples. And let's zoom in over here. Let me see if I can orient this model to my liking. So maybe something like this, right? So let's look at these degrees of freedom. So here, if we look at the translation along the first degree of freedom, that would be in this direction. If we look at the neighbor here on the right, You can see that the first degree of translation or first degree of freedom is along this axis. And one trend for these degrees of freedom, the degrees of freedom are parallel. So now let's take a quick screenshot of this. And let's define some vectors in these degrees of freedom. So let's go here. Let's go ahead and say we want to define a vector 1, 1 or 1, 0, 1. So let's go ahead and do that. Say we want to define this vector 1, 0, 0. So here we start at this coordinate system here on the bottom left. Okay, so we go along the x, maybe go up to 1, and then that would be the vector. Now, what about this coordinate system here? Okay, well, we'll go 1. That's the vector. And then here along the third coordinate system, that's the vector. So these are the 3 vectors for this vector, 1, 0, 0. So let's go ahead and go to the other degrees of freedom. So these degrees of freedom on the right are going to be using a cylindrical coordinate system. So maybe let's go ahead and display that right now. So here is the local cylindrical coordinate system. The degrees of freedom are following that local coordinate system. So let's go ahead and now look at those coordinate systems. Now there's a very big difference. Whereas before, the first degree of freedom for each node was going in the positive x direction. Now in these other nodes, the first degree of freedom is going in the radial direction. So here, let's zoom in. So that red axis is now going in the radial direction. Now this is very important because the vectors that you're specifying now are going to vary from observer or to another observer. Now that's why you see these stick figures. These stick figures are there to help communicate the fact that when you define vectors, your vectors are going to vary depending on the coordinate system that's being used. So it's always important to ask, whenever I define a vector, in what coordinate system is that vector being defined in? In whose reference frame is that vector being observed? So for this coordinate system or this person here, what does this vector look like? So here we'll go along the x-axis, and here's 1 maybe, so we'll draw a vector that looks like that. What about this next observer? What in this coordinate system, what does that vector look like? So the vector might look a little something like this. And then for this third example, this third observer, what does that vector look like? And the vector might look like that. Now this is very different from this other cylinder that we have. So here, all the first degrees of freedom, the translations along the x-axis, they were all parallel. They were going to the right in this image. But for this new set of degrees of freedom, the x-axis, if you will, for the degrees of freedom, it's going in the radial direction. So this is very important for us. Whenever we define that orientation vector, it's being observed in these degrees of freedom coordinate systems. So you can imagine that there are different stick figures, there are different persons at each coordinate system. Each one of them is going to be observing this vector differently. So let's go ahead and exit this. And let's move to another part of this model. So here you can see that the vector 1, 0, 0 is going to be in this direction. And then if we look at this coordinate system here, so this would be the node. The vector 1, 0, 0 is going in this direction, like you see here on the screen. So now that we know the orientation vectors are being defined in the displacement coordinate systems, let's go ahead and now configure the orientation vectors. So to do this, you would open the orientations panel here on the left. For the target, you would select the C-bar element type. And then here, let's go ahead and just say, let's manually specify the vector. So we're going to specify the vector in the displacement coordinate system. So we'll type in 1, 0, 0. Here, uh, the wording in the documentation. Sometimes they use displacement coordinate system. Other times they'll use global coordinate system. So here, global and displacement coordinate system are the same. And then here, let's go ahead and select some beam elements. So let's go ahead and select all these beam elements, and we'll go ahead and do the same for this one too. And we'll go ahead and do that for this set of elements, and then this one too. I really don't like this label being in the way, so we'll go ahead and turn that off. And then back in orientations, let's go ahead and make sure we've selected all of these beam elements. Okay, so now let's go ahead and click apply. And now these are the new orientation vectors. So now you can see that these orientation vectors are going in the x-axis for each degree of freedom. But here, the x-axis for the degrees of freedom, they're actually radial. So you can see the orientation vectors are aligning to the respective x-axes. Now, if we wanted to, we could display the cross-section. And then this would give you an update of what the orientations look like. Here, you can see that for one of the examples, the beam shapes look properly oriented. So maybe we can say we're done here. Here, some of the beams are correctly oriented, but the other beams are not. And all has to do with this orientation vector. So you can see that I'll call it the up direction for now, but the up direction is different for these beams than it is these beams. So we have to fix that. So, okay, let me go ahead and say another thing. So let's suppose that you did want to use these coordinate systems. You don't want to use each individual coordinate system like you see here. Say you wanted to use the, well, some will call it the basic coordinate system. So what you can do is the following. You can change this to basic. And then here, maybe I'll change this to the y-axis. So let's go ahead and change the vector to go in the y direction. So 0, 1, 0. We'll use the basic option, and then we'll click apply. And now all of the orientation vectors are the same because we're using the basic option. We're no longer using those individual degrees of freedom to define the vectors. We're using the basic coordinate system to define our vectors. So here, all the vectors are the same. And then we'll go ahead and modify these even more. Suppose you wanted to do this. Let's go ahead and hide this. And maybe we'll hide the beam sections for now. Suppose there was a node and you wanted the orientation vectors to follow that node. So right now, all the orientation vectors are pointing in this direction. Suppose you wanted to do this. For these orientation vectors, say you want them all to point to this node here. How do you do that? You can select the GO option. You can click a node. So let's go ahead and maybe click, make this a little smaller. So here's the blue point that we just selected, the node. And let's go ahead and select some beam elements now. Let's go ahead and delete all of these. And let's go ahead and select all these beam elements here. Let's go ahead and make sure we did this right. Okay, now let's go ahead and click apply here. And here's the update. You can see all these orientation vectors are now pointing to that node we selected a moment ago. This may help you, this may not, but I wanted to throw that in there just in case you wanted to know how to use that option. There is a much simpler option if you're using 2D elements. So let's go ahead and display the 2D elements. Let's go ahead and display the wireframe from the beam cross sections. What you can do, you can say, hey, you know what? Make my beams be on the plane of these 2D elements. Make the beams normal to these 2D elements. There's an option to do that here in the orientations panel. Under field name, you would select x1, x2, x3 based on 2D element normal. So select that option. Click on the pick icon for the 2D elements. Here in this pick filter, select 2D. Click on the plus icon. Now select the 2D elements that are touching the beam elements. So that would be these elements here. Next, you will select the beam elements you want to modify. So let's go ahead and see if we know where those beam elements. Right. So we've already selected those beam elements. They're in blue here. Always make sure that you're selecting the right property or entity type. Here in the filter a moment ago, I had 3D elements selected. That was wrong. Make sure you select the 1D here. Now, when we click apply, let's go ahead and make sure we did this right. I suspect the beams, oh, they've been, well, these beams were already in the correct direction. So let's go ahead and use other beam elements. Let's use these beam elements instead. So for this, let's go ahead and select these. Oh, they've already been selected. So let me look at this. Yep. Oh, okay. Got it. So let's select some additional 2D elements. So let's go around the ring and select all of these elements. So remember, you have to select at least one 2D element that touches the beam. Once you know which 2D element to use, it's going to go ahead and create or perform the orientation. So here's the result. So all the orientation vectors are now normal, perpendicular to the 2D elements that we selected. So if we walk around the model, you can see that that was the case. So now let's do the same for these other ones. So what's the process like for this? Let me go ahead and delete all of these old elements. And now let's repeat the process. 2D elements. Let's go and select those here. Now, you can make this a little faster if you want. You can increase the picking sphere size. So it's okay if you select elements that are not touching the beam elements. That's perfectly fine. But at a minimum, the 2D elements should be touching the beam elements. So that's one set of 2D elements, and then we'll go ahead and go here. We'll do the same. Now, personally, my favorite option would be this approach. The orientation vectors based on 2D elements. Because no matter how complex the surface mesh is, this will be able to orient your beam elements properly. So let's go ahead and select these other ones. So here, if you look at these beam elements, you can see the orientation vectors are all pointing the incorrect direction. So we have to fix that. First, we'll select the 2D elements. And it's going to rotate this, and then we'll continue on. And like I said, at the minimum, you should select 2D elements that are touching the beam elements. So that would be this row of dots, if you will. It's okay if you select other 2D elements. That's perfectly fine. Now, we've selected the 2D elements. What about the 1D elements? So like before, we'll do the same thing. Let's go ahead and select those right now. And we'll just go around the cylinder and select all the beam elements. Now, while I'm doing this, a quick reminder that if you want to follow along with this exercise, again, there's a free trial. You can visit theengineeringlab.com, and there you'll find a blue link, a blue button. Click the blue button and sign up, and then we'll get you started with the free trial for this tool. So we'll go here, we'll select those beam elements, and then we'll go around the ring, just continue selecting beam elements. And then we'll do that for this last set of beam elements. Now, one thing that you should know about this picking sphere, it kind of locks on. It locks on to these lines that represent the orientation vectors, and sometimes it conflicts with picking. Here on the bottom right, you can click on Reset Display. That will remove those orientation vectors, and then you will have a better time at selecting beam elements. So the fewer graphical objects you have on the screen, the easier it is in picking objects on the screen. So let's go ahead and finish that. And one thing I like to do, just in case, I like to back up the list of element IDs that I've selected. So we'll call these beam element IDs. Something might happen and I lose the list and I have to repick everything, but here we've created a backup, and we'll do the same for the 2D elements. So we'll say 2D elements IDs, we'll paste that here, and then we'll call these backups. So again, just in case I have to redo this whole procedure, I have the list of IDs that I've selected. Okay, so we've selected the 2D elements, we've selected the 1D elements, and now let's go ahead and click apply, and now let's look at the new orientation vectors. Okay, great. All the orientation vectors appear adjusted to how we want them. They're pointing, if you will, in the radial direction. Now, one thing to note in this, if you open up the pre-web app and look at the C-bar elements, the orientation vectors are defined in the X1, the X2, and the X3 fields. You notice that all of those values have been updated. So these are the values for those orientation vectors. Also, the offset property, that would be this column OFFT, it's already been set for us. I do not recommend manually modifying it here. Let the orientations panel do the work for you. If we open up the preview, we have an idea of what the updated bulk data entries look like. You can see the orientation vectors are defined in fields 6, 7, and 8, and then the offset field is defined in field 9. So just letting you know that, hey, your entries are actually being modified. Okay, now let's work on the offset. One thing about these beam cross sections, they are going through the cylinder wall, so we have to fix that. So let's go ahead and do this. Let's go ahead and turn off some of this. Let's go ahead and look at the element coordinate system. So if you click on orientations panel here, click on display ECS, or element coordinate system. When you do that and zoom in, you will see the coordinate system for each beam element. So the beam offsets, depending on the option you use, if you use the, I believe it's the O option, right? So if you use the offset option here, I know it's a little confusing. I'll call it the O. If you use the O option, not the G option, if you use the O option, the vector for the beam offset is going to be defined in the element coordinate system. So you can imagine the beam offset is being viewed from this observer. So here we'll say, you know what, I want to move these beams along the positive Y element axis. How do we do that here in the web app? So let's go ahead and modify the W1A option. And here for the vector, we'll say move this along the 0, 0.04, 0. And then I believe we need to select some beam elements. Let's go ahead and make sure. Okay, yeah, so I need to add these beam elements to the selection. And remember, the more objects you have on the screen, the more difficult it is to pick. So here, these axes might conflict, so I can click on Reset Display, and then they're gone. And then I can add these beam elements. And let's go ahead and close that. Then let's click apply. And you'll notice that now I've offset one end of the beams. If we look at the cylinder now, you can see that the beams, at least one side of the beams, are above the cylinder wall. Now, we have to repeat this for the other end of the beam. One end is called end A, and the other end is called end B. So here we'll select W1B. We'll use the same vector, the same element IDs, and we'll click apply. And there you have it. These are the beams that we wanted at the beginning of the video. So if we go back here, these are the final beams that we wanted. At this point, this is what you can do. You can go to the pre panel, you can go to download. You can click on download PDF. And then if you look at your desktop, we'll rename this file cylinder updated. Let's go ahead and open this in a text editor. You can see that all of our C-bar elements have been updated with those orientation vectors that we defined. Now, what we can do back in the original tool that we were using, remember, sometimes you have success with the beam orientation vectors, sometimes you don't. And that's okay, that you have various options to configure those beam orientation vectors. Here, what we're going to do as a confirmation, we're going to take those beams that we've modified. We're going to open a new Patran session, and we're going to import those new beam elements. So let's go ahead and do this. Right click, import. We'll go ahead and select cylinder updated. And then we'll go ahead and go to display, load, BC's element properties. And then for beam display, we'll say 3D full span and offsets and apply. And now you see that the same beam shapes that we saw in the web app, they're now in Patran, and they have the orientation that we wanted. If you recall earlier in this video, we started off with really odd oriented beam elements, but here we took the time to go ahead and modify those beam orientation vectors. So let me do a quick summary, and then I'll show you a few additional capabilities in what we discussed today. Whenever you define a vector, it's very important to ask in what coordinate system are the vectors being defined in. So here we realize that those beam orientation vectors are often being defined in the degrees of freedom for each node. So this is the degree of freedom for this node, the degrees of freedom for this node. These are the degrees of freedom for this node, and for these nodes you can see that the degrees of freedom are varying. They're changing direction, if you will. That's because these are using the cylindrical coordinate system. These other degrees of freedom, the x-axis, I believe, is all pointing along the positive x, right? So this is going to the left, going to the left, going to the left here and here, left, left, and so on and so on. So it's in those reference frames, if you will. It's in those coordinate systems, right, degrees of freedom, that many times your orientation vectors are being defined in. You can modify this. You can modify this to use the basic coordinate system, but you can see that that just adds more and more confusion when you're creating the beam orientation vectors. So here, what we did in this video, we said, take a lot of that confusion and let's just use this panel to do our orientations for us. What we went ahead and said was, you know what? Rather than me manually specifying the orientation vectors, let's just say this. Point the orientation vectors so that they're perpendicular to the face of the cylindrical wall, or normal to the 2D elements. And that was the result, like you saw here on the screen. Now, one thing we're going to do, we're going to use a different option here for the orientation vectors. So here, remember, I backed up the list, so we'll just go ahead and copy and paste those IDs here. And then we'll do this for the beam elements also. So if we look at the 2D elements, go to make sure those are selected. Maybe, yeah, that's okay for now. And then here we'll go ahead and see which 1D elements. Okay, so that's good. So we're only going to modify these beam elements here on the top, and then these beam elements on the bottom left. Now I'm going to use this option called reverse the vector and click apply. So you can see that the original orientation vectors for these elements are unchanged. They were not modified in this action. But we said use the reverse of the orientation vector. So these other beam elements, the orientation vector is now reversed, like you see here on the screen. If we look at those cross sections, you can see that. Let me see if it's a little hard. Or let me do this. Let me hide the wall for now. So these beam cross sections were pointing in the outward direction. And we noticed because we saw the orientation vectors a moment ago, they're pointing towards the outside of the cylinder. But these other beams, they're pointing, the orientation vectors are pointing towards the inside of the cylinder. So you can see that the beam shapes are actually flipped or reversed. So that was one of the last options, the reverse vector option. Okay, so there we have it. That's an overview of the orientation vectors. Hopefully you found it useful. I know they can be really confusing. I recommend doing this. If you're new to this, don't spend a lot of time here. Don't spend a lot of time modifying fields 6, 7, 8, and 9, or fields 14, 15, 16, 17 through 19. Don't manually modify these here. Use the orientations panel. Experiment with all these different options until you get what you want. Then export the bulk data file and then bring it back to whatever tool you're using and then continue your work. So that's my recommendation. Okay, that's pretty much the end of the tutorial. As a reminder, if you want access to these web applications, you can visit theengineeringlab.com. Here in the top right hand corner, you could click free trial pre-post web app, fill out the form, and we'll go ahead and grant you access to a free trial of these tools. So that's the end of the video, and thank you for watching.